Okay, so I'll be quick, 15 minutes. And I typically like actually sharing some mistakes. And I mean, maybe that's how Seven and I started working together, talking about sort of mistakes you can make along the process, and we all do them. So I think I really appreciate your initiative, Seven, but I think it's fantastic. And also, I mean, we should be discussing what we learned from and what we typically don't write so explicitly in papers and talk about during presentations. So I completely love this idea. Let's hope I don't disappoint too much, but let's see. Okay, so I'm going to talk about the specific paper that was recently published, and I'm not going to give you much detail more than what we did and the results, and then we'll come back to all the behind the scenes of that particular project. So before talking about sort of replications of others, sort of studies that we successfully versus unsuccessfully replicate by others, I like to start with an example that I typically point out, like a failed replication of myself. So this is a study that we published now, 15 years ago, 16 years ago. We did the study almost 20 years ago. So this was a study where we were interested in variation in dopamine receptor genes and risk-taking. Why? I mean, the dopamine system is related to the reward system. So we thought that, okay, maybe variation in specific genes related to this system can help us understand variation in risk-taking between individuals. So what do we do here? We have a sample of 100 men. We look at 2 specific dopamine receptor genes. Why only 2? This is at the time when it was expensive to do genotyping, so that's what we could do for this particular study. We find a null result for one of the 2 genes. We report this in the paper, but it's not in the title of the paper, and it's not really emphasized much, but it's still reported. So at least we're not hiding it. We're just not being like, ta-da, big null result. But what we do find, and that's in the title of the paper, is that those with the longer version of this specific DRD4 gene are statistically significantly more risk-taking than those with the shorter version. So here's the p-value, survives some multiple testing, but it's just not very interesting. Why? With this type of sample, we have absolutely no statistical power. 0. Even if you're trying to be Bayesian here, with a sample size of 100 when trying to look at genes and risk-taking, or genes and whatever, candidate genes in general, you have no statistical power. We didn't realize it at the time, so we spent so much time, money, and effort chasing this, basically trying to figure out, oh, can we replicate this? Can we extend this to other samples? Look at other types of risk-taking. And it was just like chasing noise, basically. And this took me several years to realize. It's also interesting, so I think that at the same time that I was sort of doing some of this work, continued along this line of research, I was also thinking about the credibility of results, replications, etc., but didn't really combine these thoughts into this particular. So this was just a complete waste of time. I haven't retracted paper because there's nothing fake, there's no fraud. I just don't believe in these results. The paper still gets cited. Unfortunately, it shouldn't, because there's just nothing we learn from it. But that's a different discussion that we can have at some other stage, or maybe you should have it with others. How do we make sure we sort of cite things that we actually should cite? But that's a different discussion, maybe. Okay, so what do we mean by replication here? So I'm going to only, I think today, given the short amount of time, and I've already spent a few minutes on this, only talk about direct replications. What does this mean? We try to redo the study, an original study, an experimental study, and we try to stay as close as possible to the original study. So we try to get the methods and materials from the original authors, and then we try to redo the study in a new but similar sample, and we try to have high statistical power in our replications. So we say that a study successfully replicates if we, in the replication study, find an effect that is in the same direction as the original study, and this replication result is statistically significant in a 2-sided test. Many people dislike this criterion because it's binary and you lose information. We also look at relative effect size. So what is the replication's effect size compared to the original one? But there are many other interesting replication indicators too, and we typically report all of them. But I'm not going to get into them very much now. But in particular, the Bayes factor, I think, is interesting to think about. Okay, so to these, so we've done a bunch of replication projects, and I'm gonna, when there is time for you to do the survey, to those of you that do it quickly, we can talk a little bit about the older projects. But to give some background, we've done a bunch of replication projects, and to these projects, we've typically added the prediction markets. So these are basically functioning as tools for us to see whether researchers can predict the replication outcomes. So in these original studies that we look at, there can be several experiments. We only focus on one experiment, and we only focus on one specific result, which of course puts limits to the generalizability of what we learn from the replication exercise, in the sense that we're not replicating every single aspect of an original paper. So that's a big caveat to consider. But that central hypothesis that we're trying to replicate, we set up prediction markets for that central hypothesis. And in these markets, participants who are often experimenters or others on the ESA web list or announcement list, we ask them to sort of bet whether the result will replicate yes or no according to this binary statistical significance criterion. So prices in these contracts that are binary can go up or down depending on how people are betting. Prices start at 50, and if you think that the study has more than a 50% probability of replicating, you should buy the contract, go long in it. If you think it has a lower probability, you should short sell it, go short in that contract, or buy some other contract instead. And of course, prices will update dynamically depending on how participants are betting here. So they start out at 15, can go up or down, and you can choose to sort of go long first and then short sell it depending on the price. What do you think makes sense? So what we want to do, we want to interpret the price of these contracts in the hypothesis replicating as the predicted probability of the outcome occurring. So what do the markets think in terms of the probability that the study will replicate? There are tons of real prediction markets out there that are open for longer periods of time. We have them open for about 2 weeks. We have between 30 and 200 participants, and we give these participants money. So you don't have to use your own money if you bet here. And we give them information about the original studies and the replications and how they differ, because they will always differ in one way or another. So we've done prediction market studies and have found that they are okay in terms of performance. I mean, there is some predictive power from prediction markets. So researchers are pretty good at figuring out which studies will replicate. So that also suggests that there is something systematic about studies that successfully versus unsuccessfully replicate. But it's far from perfect, okay? And so Sev and Daniel Evans and others have more work on this topic. But at the end of the day, I mean, there are so many potential replications that could be run. So then we were thinking maybe we can use these markets to help us choose what to replicate. So we move from prediction markets to decision markets. With decision markets, we let prices in the markets guide us how to move forward. So we basically pick a set of studies and we say they all have a positive probability of being picked for replication, but we're going to give extra weight to certain studies depending on our decision rule. So we could tell market participants that we're going to use a decision rule that puts the highest weight or more weight on studies that have the highest degree of uncertainty in the outcome, prices that are close to 50. So the information value from a replication would be the highest. Or we're going to put extra weight on studies where there's the most disagreement between those that trade, or something else. So what we decided to do in this particular paper that was published in the fall of 2024, we decided to use a selection rule where we say we have a set of 41 studies that we could potentially try to replicate. We're going to for sure replicate the 12 studies that have the lowest prices in these markets, the 12 studies that have the highest prices, and 2 random studies. And we scale payoffs according to the probability of being picked for replication. So we consider this sort of a proof of concept study, while sort of realizing that power is an issue. At the end of the day, we would have liked to do this for 400 studies, so we actually really can say something more interesting. But if you have been or were thinking about participating as a trader in one of these studies, you can sort of figure out that just reading 41 studies and looking at replication material for that is quite some work already. So scaling this up is not that easy. So just saying that I realized that our power issues here. So what did we choose? We chose to look at social science experiments that were all published in PNAS, a specific time period, 2015-2018, that had been run on the online platform mTurk. We only look for studies that have between or within subject treatment designs that are logistically feasible, and we can come back to this later. And they had to have at least one statistically significant main or interaction effect in the main text. I've already told you about this sort of decision market setting. So we replicate 26 studies, but we get predictions for all 41, and then we have this transparent decision rule, which I don't think is the most interesting one, but it's good for the proof of concept test that we want to do here. So who are the participants in these markets? Researchers like you, basically. So we mainly reach out to experimentalists on the ESA email list and the JDM email lists. And this also puts some limits to what we can learn from a specific study, I think. If we find that the markets perform really well, it's maybe partly because of the studies we chose, partly because of sort of how much power do we have in the replications, and very importantly, who chooses to participate here as a trader and make predictions. And that's not something we fully control. So there are some limits to generalizability in every single project we do on this, I think. At the end of the day, for this project, we had 162 social scientists who traded quite actively. Before participants enter these markets, we give them a survey where we ask them, what probability do you assign this study replicating? And we give them access to replication reports that are basically 2-3 pages, more 2 pages than 3, about how it shows the original result, how we are conducting the replication, and sort of how we differ from the original study in one way or another. Inclusion criteria is typically the same, etc., but there might be some change to something somewhere. These reports are also shared with the original authors for feedback. And if nobody has any points later or questions or comments, we can always discuss sort of mistakes that were made in this type of communication, because I think we've made many mistakes over the years and learn, and then you make new mistakes, and there's something we can still learn. So when it comes to replications, as I said, we basically have the same sample restrictions and exclusion criteria as the original studies. So one thing that we can discuss for the previous project is that when you have 90% power to detect 100% of the original effect size, this might sound good in many ways. But if you think that even true positive results tend to be exaggerated once they're first published, you're not that well powered when you have 90% power to detect the whole original effect size. So we've learned this a little bit the hard way, and nowadays we try to have higher power than that. So in this particular project, we have 90% power to detect 2/3 of the original effect size at p less than 0.05 in a two-sided test. And we also add the constraint that we have to have at least the same sample size as the original study. So average sample size in our replications is about 3.5 times as large as the average sample size in the original studies. And I think this is good and should be considered when you do replications. So we were basically 5 teams that were planning and running the replications. And you can see the list of teams here, so great collaborators at many different places. We ran these studies on mTurk, for better and for worse, in the sense that the original studies were run on mTurk, we run them on mTurk. Many people were and are worried about quality of data that you get from mTurk or other online platforms. So for that reason, we had attention checks and also IP quality checks before participants were randomly assigned to treatments. So almost a third of our participants failed these checks and were excluded from the IP check. So they had passed already the attention checks and then failed on these other checks, which is a little bit worrisome, I think, but that's a different discussion maybe. Participants could only participate once in a specific study and had to have a hit approval rate of at least 95%. We had a show-up fee, and then we used the same incentives as in the original studies. So what are the results? So we have these 26 studies for which we have predictions and we have replication outcomes. So in green, we have successful replication outcomes, meaning that the study successfully replicates according to our binary statistical significance criterion. In purple, we have failed replications according to this criterion. In white dots or circles, we don't have a replication outcome because these studies were not picked for replication. So we have the top 12, the bottom 12 according to the markets, and then 2 random studies. So what do we find? We find an okay, I think, correlation between prices and replication outcomes. So an R of 0.5, and this we would say is suggestive evidence with a P equal to 0.008. So the markets are pretty good, not perfect. Out of the 26 results, 14 replicate. We can come back to whether this is surprising or not 14 out of 26 results. There's some suggestive evidence that the replication rates differ between the top 12 and bottom 12, but this is not a very high-powered test. We can also say something about average relative effect sizes. So if we look at the green studies, those that successfully replicate according to the binary statistical significance criterion, effect sizes are about 70%, the relative effect size. So even true positive results tend to be inflated, and this is something we see in study after study. And the relative effect sizes are fairly close to zero for the ones that fail to replicate. So that also tells you that something about the alignment of relative effect size and this binary statistical significance criterion. What have we learned from this? I think we learned that markets can help us a little bit, but they are not perfect in helping us predict which studies will replicate. So we need to do the replications and actually to learn this. But there is something systematic about results that successfully versus unsuccessfully replicate. Original p-values are also relevant. So that's something we can see from all of these replication projects. And I don't think participants necessarily incorporate this enough. If one were to do other projects on decision markets, I think other selection rules could be even more interesting, like putting extra weight on studies that have prices close to 50, for example. And just final slide, I do a lot of work looking at replications among experiments, and this does not mean whatsoever that sort of the experimental community is the community that has the most problems with studies that fail to replicate. I mean, the beauty of experiments is that we can actually redo them, and we can take things like power and causality, etc., seriously. And this is a luxury that most other fields do not have, where potentially you could get access to the same data, but you cannot run the same natural experiment again. We can do the same experiment again. So I think sort of the fact that we can study it doesn't mean that we have more of a problem. If anything, the problem seemed to be worse in other subfields of economics, unfortunately for economics as a bigger field. So here's from this very nice paper by Brodeur and co-authors from 2016, where they look for evidence of p-hacking in different subfields of economics. And the category where there's the least of this is the category lab experiments or RCT data. But we can discuss this further. I have tons of co-authors, and this would not have been possible with all of them. Fantastic, and thanks everyone for being part of this. And that's it. Okay, let's move on then. Batal.
Amazing. Thank you so much, Anna, for the introduction. I'm going to now share the link to the survey that all of you can start filling on the chat. So you should be able to access it now. And as we're doing that, Anna, do you want to talk about your work on replication in general?
Great, yeah. Then I continue. I mean, it's not about that project anymore, but so sort of that we get to talk about something. So here is this it? Yes, okay. So I can give you a little bit of a background on these other projects, and this might be useful to consider when we think about this 14 out of 26 and sort of differences between fields, etc. So part of this, I mean, I already alluded to how it started for me, which was partly about my own failed studies. And coming back to this dopamine receptor gene, I think we did at least 3 studies, I think. And it, of course, became harder and harder to find that main result. But in a subgroup somewhere in the sample, because the subsequent samples were a little bit larger, it was possible to find something. But at the end of the day, all these were just false positive results, very likely. Okay, but then a big inspiration for many, I think, in thinking about meta science and replications was, of course, this Open Science Collaboration 2015 paper, which was led by Brian Nosek and others, where the goal was to try to replicate as many studies as possible from 3 top psychology journals in 2008. At the end of the project deadline, 100 replications had been completed. The idea here was to have high power, so 90% power to detect 100% of the original effect size. There were 270 authors on this. I'm one, and I played a very small role on this. And at the end of the day, so you had these 100 original studies, 97 of them reported to have statistically significant positive results, and 35 had so among the 100 replications. So this then led to headlines like, okay, there is a replication crisis. Obviously, many results did not replicate. So it's very much inspired by that. Together with other colleagues, we decided to try to do something related, but also more small scale in experimental economics, where we looked at two top econ journals, specific time period 2011 to 2014, searched for all experiments testing a hypothesis in a between subject design. We again thought we had high power, but we have 90% power to detect 100% of the original effect size. So I think for both this and the other project, power is an issue that so one should take the results with some grain of salt, I think. So we only look for studies that report a statistically significant positive result. So we have 18 such results, 11 replicate according to this binary statistical significance criterion. So in the subsequent project, we decided to take power more seriously. So we decided to try to replicate like social science experiments, behavioral economics related things, psychology, that were published in Nature and Science time period 2010 to 2015. We find 21 papers that we could potentially replicate. We exclude some papers for various reasons. At the time, we didn't think we could do studies on men smelling tears versus water and looking at testosterone levels of these men. Now we could. So, I mean, that would have been fun to try to replicate. But so we don't have such studies. We have others. We have 21 replications. We have way higher statistical power here. So we do potentially 2 stages of data collection, so that the maximum power we would have would be 90% power to detect 50% of the original effect size. When we have such high power, we find that 13 out of 21 results replicate. So from these projects, we had added prediction markets, and they perform okay, but not perfect. Those were some things I think I wanted to, given that I had time to do the background before, or did not have time to do the background before the presentation. That was the background that I would have had normally for a normal presentation. But this is not a normal presentation, right? Are we ready now, Vatsal, to...
Yes, we should be. So just in case any of you haven't had a chance to fill the survey yet, now would be the time to do it. I'm going to share my screen now, and we're going to go through the responses one by one. And yeah, Anna, please feel free to, wherever you want to discuss more. I think that's the idea, so we can make this interactive. Okay, so hopefully you should all be able to see my screen. Got around 40 responses so far. I'm happy to wait for a bit, or go ahead, Seb, what do you think?
Yeah, let's go ahead.
All right, okay. So let's just see. So the first question is, how many years do you think it took the researchers to go from conceiving the idea to getting it published? And we can see the responses so far. And I'm gonna not show the true response just yet, because we have like a few more people who are filling it. But you can see it. Yeah. Change live. And okay, let me show you the correct response now. So it took them 7 years to do this. So Anna, do you wanna discuss this?
I mean, 7 years from conceiving the idea, then it took us, I don't know, a few years to actually think about the design. And I think a big hurdle was, how do we choose which studies to try to replicate? Like, okay, we had looked at we had looked at a subset of journals in economics, etc., for a specific time period. So of course we could have extended that time period for economics or something, but we wanted to look at general science, behavioral econ related things. So we decided for PNAS, and then we spent a lot of time thinking, do we do lab or online? Online showed up later. This was pre-pandemic. And then we were basically ready to run this when the pandemic hit, and we thought we can just continue. Everything works online. But then we got a lot of pushback from some original authors who said, I mean, it doesn't make sense to do replications during a pandemic. And we decided to postpone everything for that reason. So that's also, but I mean, things take time. I found an email that we had written 7 years ago in the project. We might have started talking about it earlier, and I just couldn't remember it. Things take time, and I guess it's good that you forget this when you do research, because otherwise maybe we wouldn't be so motivated.
All right, thank you, Anna. Let's move on to the next question. So the next question was, how many times do you think the presenter, so how many times do you think Anna presented the paper at an external conference or a seminar before submitting it to a journal? We've got 48 people who filled it, so I'm going to show you the responses now. So most of you said that it's been presented more than 4 times. And Anna's response is 3 to 4 times. Anna, do you want to talk about that?
I mean, yeah, I just didn't have that many occasions to present it, and we submitted it fairly quickly once it was actually ready. And then once, so sort of sometimes when you submit to these general science journals, where we ended up publishing it, it's not clear sort of what the rules are in terms of how public one should be with the results. And I think in the beginning we were planning to not present them that much, but then it was just like, okay, this is ridiculous. What are we doing? We of course want to talk about the results. So yeah, that's
Right.
the 3 to 4 explanation.
Yeah, I guess I have a question. I guess a related question is, how many times did you have a large team of co-authors? So how many times did the team present it? Was that a lot more than?
I don't think so. I think we were not presenting it much during the work of the sort of paper.
Right. Thank you. Okay, let's go to the next question then. How many journals do you think the researchers received a rejection from before the paper was accepted? Let's see what we've got 48 responses here as well. Let's see what people said. All right. So there's quite a distribution here. And let's see what the right number is. That's 1.
Yeah, we submitted it to Nature and had it desk rejected. So then we submitted to Nature Human Behavior. It was sort of expected to be desk rejected, but it was still worth it. I think the big cost is jumping between natural science or general science and econ papers. Though I think that's become easier now than it was like 10, 15 years ago when you were, at least I was like manually doing references and stuff. Now that we're not, things are a little bit easier. And yeah.
Did they give you a rationale at Nature for the
Yes.
decision?
Not of enough interest. I think that was fair enough.
This is not on the on our list of questions, so feel free to not answer it if you don't want. But like usually there's a lot of gap between the first time you get a rejection. Like there can be a lot of gap between the first time you get a rejection and you submit it again. So how do you think about this, and how was that for you?
Yeah, so in this case, I mean, the good thing about many of these general science journals is that they desk reject quickly. So it's a matter of days or maximum a couple of weeks, and then you move on. And we didn't change anything in the paper going to the next journal because there was nothing to change, because there was no information to change it based on, basically. So that was, it's different if you get interesting review comments that you have to consider, which we wish we would have had here, but that's not. I mean, good that journals are fast. We should be faster in economics, and I think we're getting faster than we used to be, and I think that's a good thing.
All right. Let's go to the next question then. I also want to remind the audience, Anna, if it's okay with you, people can just also jump in with questions if they have.
Please do.
Them. Yeah. All right. Okay. So how many rounds of revisions do you think the paper went through after receiving the first response from the journal where it was published? So let's see what people said. Okay, everyone almost agreed on 2 to 3 times. And the truth here is 3 times.
Yeah, so it was an interesting experience. I mean, there were several reviewers. One was basically, I mean, nobody was fully happy after the first round, and I think that's the sort of normal thing. And then there was someone who basically said minor revision, and someone who said reject. I don't know if they said reject, but I'm guessing that's what they did. And then additional reviewers were also brought in at various stages and dropped. So I think the first one that was very positive was not involved anymore, and others were. And I think the journal wanted to have lots of opinions, which is typically a good thing. And this was also sort of expected to me in the sense that when do you get the paper accepted almost on the first round? Almost never happened to me. So it would be interesting to have that experience, but I've almost never had that. And I think the paper did improve in some ways, and I think maybe we added some things that reviewers asked that did not very much improve it, but at least we're trying to be transparent in the paper with what was actually stemming from our pre-analysis plan and what came from reviewers suggesting it. I mean, there are lots of discussions about pre-analysis plans and how to relate to them in the paper and show what the reviewers versus editors, etc., want you to do. I think one can be fairly transparent about that and just say, this is not what we had planned to do, but as suggested by the reviewers, here are the results for this analysis. So that was part of the revision process here.
What were the main complaints? What were the main things that you had to address?
So there was a lot of discussion about this, the usefulness of this binary statistical significance criterion, and also about relative effect size, and sort of that something like the prediction interval approach could be better. And I disagree. And so we had added that particular approach to our pre-analysis plan, and that was something we chose to not add. At the end of the day, we now have it because of reviewers, and that's transparent. I think the other replication indicators are more interesting. But I guess, I mean, you choose. You can read a paper and see what you think makes sense. And I think that's completely fine. But it was a little bit risky, I think, for us deciding that, look, we've reported this in many presentations, and we didn't, or in many papers, and we didn't want to include it as one of our pre-registered measures now, because we just don't think that it's super useful in this context. And maybe that came back biting us a little bit. Might have still have been worth it, but because readers can tell that we didn't find it so important, given that we chose not to include it in our pre-analysis plan. Okay, I see there's something in the chat here. Maybe back to the presenting. It seems in economics, acknowledgements is a signal in submissions and conferences play a large role. Do you have thoughts around this or a strategy? If I'm off based on this part, not being blind, please excuse my misunderstanding. No, so I think that in general science journals, you don't see much about, oh, thank you, audience participants here and there. And maybe there is some signaling going on in economics. I don't know. There probably is. And I just, yeah. Maybe someone else has something more interesting to say than I did on this.
What about acknowledging contributions? So I was kind of thinking about the fact that, of course, in other journals, often you have to make statements about the contributions of various authors. What do you think about that in general? I mean, the structure of teams might differ, the roles are played. Sometimes it might be good to remain kind of, not too precise about what the contributions were, to be, as encompassing as possible and protect maybe, different contributions. What do you think in terms of how to do this?
I think these statements are useful for, I mean, I don't really see the costs of having them. I only think they bring benefits, but I'm probably missing something. I think it's pretty useful to see sort of who did what in the project. And otherwise you are guessing. And there can still, of course, you can mean different things when you say like the data collection. Someone can have done a big chunk and others less, but at least sort of tells you something. And I think it's particularly useful for these like team science papers like this one, where there are many authors. And I only see benefits, but I'm probably blind to something. So what do you think? Anyone else? What do you think? What are the costs of making this clear?
I mean, I can see like a danger is, of course, when there are power dynamics. How do you agree on who contributed to what? Who decides, what to write on these things? So if an external observer could determine this, it seems that it would be more fair to have something like that. But in practice, how implementable?
No, you're right. And I mean, I self-servingly think that when I was part of writing down who did what, that I of course do it fairly, which is maybe someone disagrees here. So that's a good point. And maybe there would be ways to actually capture this in better ways, like more objectively in the lifetime of a project. If you have some project page using Slack, or I mean stuff that I don't use, I wouldn't really know how to do it, but there are probably ways to do this better.
All right. Okay. I just want to make sure everyone can still fill in the responses if they want to. I think, yeah, it's turned on, so it should be fine. Yeah, let us know if you have any difficulty accessing any part of the survey. The next question is, how much do you think the research question evolved during the journey of the paper? And here, yeah, Anna, do you want to talk about this? Because when I read your response, I was also surprised a bit. So do you want to talk about that?
But maybe I misunderstand the definition of a paper here, in the sense that once we had the pre-analysis plan and stuff, then it didn't change, and the research question didn't change. I mean, sometimes, yeah, reviewers tell you run these extra treatments or add this experiment or this type of data and whatever, and then, yeah, the paper transforms. That didn't happen. I mean, sure, we added like a replication indicator we didn't think was particularly interesting, but that didn't change the research question. So I think it really didn't change much.
I guess I was more asking about like the idea when you were just discussing it with your co-authors, and up until the pre-analysis plan, was there a lot of difference in what your ambitions with the project were in the very beginning?
Yeah, so then it was more, because then it was all about like, okay, how do we choose which studies to replicate? And how close do we stay to them? I mean, I can still think back to this and be like, did it make sense that we chose to stay on mTurk? Should we have gone to prolific instead, given that so many people are saying that mTurk is worse than prolific in terms of data quality? Was that the right decision? I don't know. Maybe we should redo this study, the whole. I mean, I'm serious. Maybe we should just do all of these replications again on prolific. But I at least it's too recent. Maybe I will want to do something like this in some time. Now I'm a little bit like, I don't want to think too much about this, which is not the right mentality, because it's not like once you publish it that you don't have to work on it anymore. It's still our responsibility. So I mean, I run into this issue once in a while, that once someone has published it, it's like, oh, now my hands are off. Now I don't have to think about this project anymore, and the consequences of the data being weird or whatever it is, or like something not documented well. I mean, I will have all of us that were on this will have responsibility for this forever. But yeah, so things like this. I mean, which studies to replicate, which ones to include, inclusion criteria. We realized some studies would be tricky to replicate, but we underestimated how tricky some of them would be. Yeah. And there were other mistakes, but we'll see if we have time to discuss this, depending on what happens now.
All right. Okay. How much do you think the final results of this paper aligned with the presenter's initial hypotheses? And the majority thought it was mostly aligned, and Anna thought the same.
Yeah, I mean, mostly aligned in the sense that we were like, the markets will probably perform okay, not perfect, not catastrophically bad. I think they performed okay. And what would have been my prior about the number of studies replicating? I wish I had written this down. And I wish we sort of had run the markets with ourselves, or done the survey part. And I think that's what we did back in the days for the experimental economics replication project, that we gave our own predictions, and we should have continued along with that tradition. But I'm not particularly surprised about the results, that a bit more than half replicate with this type of power, etc. My prediction is that if you look at more recent papers, substantially higher share will replicate. But now I made a public prediction that one could test in a different project.
All right, thank you. What do you think was the most challenging part of this paper for the researchers? And we were asked to rank them from the most to least challenging. I see. So it's almost, well, quite a lot of, most of the people thought that data collection was the most challenging, and then developing the research idea, navigating the peer review process, then data analysis, and then writing and structuring the paper. I don't have Anna's two responses on the screen right here. Anna, do you remember them? I can also
I don't remember, but this looks close to what I had, in a sense that I think the writing and structuring was the least, data analysis was the least, and then the peer review was a little bit messier than I expected, in terms of like new reviewers showing up and old ones disappearing. So new reviewers, new concerns, sort of that weren't addressed in the first or second round and show up. Developing the research idea was challenging, but not in a boring way, like more in a fun way. So maybe challenging is a wrong word. Data collection was a little bit challenging, but that was maybe partly reflecting sort of that I knew very little about these, how to set up such studies and with the IP quality checks, etc. But luckily, I had a fantastic research assistant who was helping with this.
Right. So I just went back and quickly just checked what you had written in our survey with this, and that's so the audience has gotten it exactly right, except the first two are flipped with each other. So the developing the research idea you said was the most challenging, and then data collection, but everything else is exactly the same. All right. What percentage of total time spent by the research team on the paper was spent on these activities? So we've got 5 activities here, and your responses must sum to 100. This is consistent with the previous response as well. And I can now share my screen and show you what Anna said, which is right here. So around 40% of the total time was spent on conceiving the idea, 30% on data collection, around 15% on data analysis, and the remainder on writing and peer review. And this would be a time when if you want to discuss the peer review process or any other backstory for which you wanted to talk about.
I mean, I feel so there were lots of discussions going on around the same time as we were submitting our paper and having done a review on like how to report deviations to a pre-analysis plan, how much can you trust when it says that a paper has been pre-registered, etc. And I think that ended up being a little bit costly for us in terms of one reviewer saying like, okay, you guys write, you have a pre-analysis plan. That doesn't mean anything to me in the sense that I have no idea whether you follow it or not. And we were like, okay, but we explicitly say that we follow it throughout. So if we don't, that is almost a call for retraction, right? If we mislead so much that we sort of, but that reviewer didn't think so, basically. But I didn't expect that. I think it's fair enough if you have different opinions about the usefulness of a pre-analysis plan. If you don't want to have a pre-analysis plan, fine. But then to say like that you're just not going to trust when someone says it when they have attached the pre-analysis plan with the timestamp, that's I didn't expect to have that discussion, and it wasn't very productive. So that was that. I mean, it didn't take up like months of my life, but it was just like a weird experience to have at that stage. But I think that partly happened because of other things happening at the same time that we were not involved in. But I think that's one of the reasons. And then, yeah, I guess that's the main thing about the peer review process. When it came to data collection, I mean, do you want to hear more about mistakes or what makes sense? Does anyone want to ask questions? Or what do you think makes sense now?
Yeah, maybe one thing you could say, and then we'll take a few questions from the audience, is something about, I mean, replicating a study can be quite stressful for the original authors. And there's this question of how to interact with the original authors once you complete replications. How do you present your efforts? How do you communicate about the results? Is there something here that you want to share about best practices and what you've learned from doing this, which seems like a difficult exercise to perform?
Yeah, so I don't know if I have any best practices to share in the sense that I don't know. I don't know exactly who would have best practices to share for these replications or replications in general. But we try to like communicate in friendly ways. And in these emails that when we contact original authors, we try to say like, look, we're not out to get you in any way. Like this is how we chose to do this. This is how we chose studies to try to replicate. And we try something typically systematically and then try to communicate this. Or if it's less systematic than in this particular process, it's typically because we find the study very interesting. But this, of course, can feel weird, and we try to be polite, and we have failed to be polite, and we have failed to reply quickly enough. And when you don't reply quickly enough, people can get very annoyed. I think if you're a little bit predisposed to be sort of worried about something, and you get such an email, of course, you can be super stressed. And So I think it's fair enough that you don't react like, oh, welcome replicators, take all my, like, I love you guys, and it's going to be so much fun that you're doing this. But I mean, ideally at some point we reach an equilibrium where people are not too worried either. And I think part of it is that if a result doesn't replicate, that doesn't mean there's any fraud. That doesn't mean that there was p-hacking or anything, right? And that's part of why I want to say, like, look, we can all make mistakes. And most of the time when you have if I have a result that fails to replicate, I will be the biggest sucker for that result. I will really believe in it so much. I fool myself and then maybe also others to some extent. But most of the time, it's not like people read your paper so much. It's mainly you thinking about that paper and result. But so I think we could have been faster, like more polite, even when we had tried to be polite. In one email, I remember writing something that I thought was super polite, and that original author was like, "You asshole," basically. So obviously that didn't work out great. I regretted that, and I really, yeah. So I think that was a big mistake. In some projects, we tried to be a little bit systematic, so we would like ask original authors for the material in the same way to make sure we have it all. And then some people are annoyed and like, why isn't it more personal? That you already had that information online. Okay, maybe, you know, was that a mistake? Maybe we should have made it more personal for every single thing, but it was also a way to make it more systematic for us. But so that was maybe a trade-off. I don't know. That's one example. Then there are things like, I mean, communicating with the original authors. A big majority of them have been super helpful in all of these projects that I've been involved in. I mean, the big psychology project I can't really speak to because we were just involved in one replication, and that original author was super helpful. But for the other projects, and in particular the experimental economics one, people were extremely helpful. In many of these others, they were as well very helpful. And then some of them failed to replicate and others didn't. But in any case, they were very helpful. Why did I want to say that? Yeah, I don't know. Now I'm just talking too much. What do you think, the rest of you?
Any questions for Anna? We have 5 minutes left. Any thoughts? Any questions at the back of your mind on how the project went?
Yeah. Hey, Anna. I wanted to ask about like heterogeneous accuracy in predicting non-replicability versus replicability. So do humans tend to be better at predicting whether a study is not going to replicate versus whether a study is going to replicate? Or can you speak to anything on that front?
So good question. I haven't really thought of it that way, but what we can say is that people tend to overestimate the number of results that will replicate.
Yeah. Okay. And then because part of what I'm thinking about from this perspective is like using this as a screening tool. Like there's a lot of talk right now as, you know, mass replications start to become more of a thing. Okay, what papers do we now start to replicate?
Yeah.
And you can imagine that, of course, that this could be a very good screening tool for that. Another thing that I think might be interesting is, let's say I have a series of papers. You now have this new thing out in RSS Open about using ChatGPT effectively to predict the accuracy. Do you think that as we try and scale these reproducibility efforts out more, that the ChatGPT stuff's going to be better than using the human prediction markets for deciding what papers should not be replicated to assess accuracy?
Yes. So, okay, very interesting question too. So there are a few older papers, and I played a very small role in one of them, that use like machine learning models to try to predict replication outcomes. And in those papers, the models were compared to the prediction markets. The markets performed at least as well as the machine learning models. That's bound to change, I think, with better machine learning models, AI, etc. And I'm guessing that there are two people here, Daniel Evans and Sev, who know this better, because I know that they are combining with Taisuke Imai all of this prediction data. So what do you say?
The increasing accuracy, by the way, was crazy. Like 3.5 on ChatGPT is like only getting like a 0.07 correlation, whereas you're getting like an above 0.8 correlation with just 4.0, right? I think that the huge increases over time.
Yeah, but yeah, so it would be interesting to see. I think I mean, I'm not going to make anything interesting on the prediction side. I think I think maybe I would do more stuff on the replication side in the future, because I feel like if you're going to do more interesting advances on the prediction side, you need to be more tech savvy than I am. So maybe Jack, you should do more of this.
Any other question for Anna? Otherwise, Anna, are you willing to take some questions? Can they contact you by email?
Yeah. I mean, anytime. So this is sort of one of my favorite topics. I'm very happy to talk about this, and yeah, whenever. So don't hesitate to reach out. And there are more mistakes we did in these studies. And as I said, we thought that we could replicate some of them. We didn't. First, communicating with authors, it was also interesting to realize that I could send like 5 emails to someone, no reply. Colin Cameron sends an email, oh, hello, Colin. Nice to hear from you. And then they can send maybe some material, maybe not. But it's that was also an interesting experience. Maybe not that constructive or inspiring to hear about, but it's like, okay, if people don't reply when you reply, ask someone else to email them. Maybe that's one type of lesson.
Maybe there is here one lesson also is maybe we're not experimenting enough on the way we do things, because maybe if we randomize, you know, who sends the communication or how the communication is framed, then we can also learn how to do better, right? In terms of our own approach. Of course, we often have at a small scale, but the more scientific maybe we can be, we can learn better how to approach these things. It was such a pleasure to listen to this, think about the behind the scenes of your project, Anna. And we are incredibly grateful for the audience engagement. You guys were really awesome and very accurate on a bunch of things. So that's really cool. We can see over time for different projects how this might change. If you guys have feedback on the format, please reach out to us. We are completely committed to doing this. We think that we have to change the way we communicate about research and talk more about how the sausage is made. So that was at our own small scale, an effort to go in this direction. And once again, yeah, thank you so much, Anna. I think big round of applause from all of us.
Thank you so much, and thanks everyone for being here. And Vasal and Sev, thanks so much for organizing this.
All right, thank you guys.
Thank you. Thanks, everyone.